Hello and welcome to Lucid Mind. This is Majid and today I'll be solving Chemistry O-Levels Multiple Choice Paper 11 from October-November 2020. You can go to any particular question by following timestamps given in the video description. Let's start. Question number 1. A student needs to measure 17.60 cm3 of hydrochloric acid. The student has access to the apparatus commonly found in school laboratory. Which piece of equipment should the student use to measure 17.60 cm3 of hydrochloric acid? A. We have a burette. Now the minimum division in burette is 0.1 cm3. So this is also the accuracy with which we can measure the volume. So the student would be able to measure 17.6 accurately. So A could be correct. B is gas syringe. Now as HCl is being measured, but gas syringe is used only for gases. So B is incorrect. C is a measuring cylinder. The minimum divisions in measuring cylinder is equal to 1 cm3. So this is the accuracy with which we can measure the volume. So the student will be able to measure 17 cm3 accurately. So therefore we can see that measuring cylinder is less accurate as compared to burette. So C is also incorrect. D is a pipette. Now a pipette is also a very accurate instrument, but it is used to measure fixed volumes, such as the student can measure 20.0 cm3 or 25.0 cm3. So D is also wrong. The correct option is therefore A. Question number 2. When calcium carbonate is added to dilute hydrochloric acid, carbon dioxide gas is released. 3 sets of apparatus are shown. Which sets of apparatus are suitable together with a stopwatch for following the rate of this reaction? These 3 are the sets of apparatus that are given for this reaction. Now when calcium carbonate reacts with hydrochloric acid dilute, it forms salt, calcium chloride, along with carbon dioxide and water. Now the rate of this reaction can be measured in 2 different ways. One is that we can measure the amount of reactant consumed within given time, or second is that we can measure the volume of gas that is being produced, which is CO2. Let's look into the first apparatus. We have cotton wool, so carbon dioxide will escape through cotton wool. This is the mass of calcium carbonate in HCl, so the mass will reduce with time. So we can measure the rate of this reaction by using mass balance. So 1 is correct. In 2 we can see that tap funnel is used for acid HCl. And we have a mixture of calcium carbonate and HCl which produces carbon dioxide gas. Gas syringe is used to measure CO2 gas, and we also have a stopwatch. So apparatus 2 is also correct. In third apparatus we can see that calcium carbonate reacts with HCl to form carbon dioxide, but the gas can escape through this thistle funnel because it is open. The rest of the gas is measured using water in measuring cylinder. So as carbon dioxide is soluble in water, so therefore we won't use this apparatus. So 3 is incorrect. As only apparatus 1 and 2 are correct, so therefore answer is B. Question number 3. Some substances may be separated using paper chromatography. The diagram shows the result of running 2 mixtures in a suitable solvent. which spot has an RF value of 0.37. Now we know the formula of retention factor, which is RF. It is equal to the distance traveled by spot divided by the distance traveled by solvent. Now the distance is always measured from the starting line or baseline. We can measure the distance of solvent, which is equal to 4.7 centimeters. For spot A, the distance from the baseline is 1.2 centimeters. For spot B, the distance is 1.8 centimeters. Similarly, for spot D, it is 3.6 centimeters, and for C, it is 3 centimeters. Let's find the RF value. For A, it is the distance traveled by spot A, which is 1.2 centimeter, divided by distance traveled by solvent, which is 4.7 centimeter. So it comes equal to 0.25. Similarly, for B, we can find 1.8 divided by 4.7, which is equal to 0.38. For C, we have 3 centimeter divided by 4.7 centimeter, so it is 0.64. Similarly, for D, we have 3.6 centimeter divided by 4.7, which is equal to 0.76. Now the closest value is 0.38, so the answer is B. Question number 4. Petroleum or crude oil is separated into useful fractions by fractional distillation. The positions at which fractions X and Y are collected from the fractionating column are shown. This is the position of X and this is Y. Which statement is correct? A. The temperature increases up the column. Now we know that the temperature is maximum at the bottom and minimum at the top. So therefore temperature does not increase, it decreases. So A is incorrect. B. X condenses at lower temperature than Y. When the temperature becomes lower upside, so therefore X will condense at lower temperature than Y. So B could be correct. C. X has a higher boiling point than Y. As X is condensing at lower temperature, so the boiling point would be lower. So C is incorrect. D. X has longer chain molecules than Y. As we know that longer chains have higher boiling point as compared to smaller chains. So as the boiling point of X is lower, so therefore the chains will be smaller than Y. So D is incorrect. The correct option is therefore B. Question number 5. Compound X is a crystalline solid at room temperature and pressure. An aqueous solution of X is tested as shown. First test is with dilute nitric acid and then aqueous barium nitrate and no visible change is seen. Second test is with aqueous ammonia, which forms white precipitate and which is soluble in excess. What could be the identity of X? The first test is for anions, which are negative, and second test is for cations, which is positive. A is ammonium carbonate, so we have ammonium ions and carbonate ions. B is sodium sulfate, so we have sodium ions and sulfate ions. C is calcium nitrate, so we have calcium plus 2 and nitrate negative 1. D is zinc chloride, so we have zinc plus 2 and Cl negative. Among these cations, we can see that upon adding aqueous ammonia, white precipitate is formed which is soluble in excess. This is only true for zinc. Similarly, for anions, When barium nitrate is added to first solution, it will form barium carbonate. Now barium carbonate is solid and white in color. So as in the test result, no visible change occurs, so therefore it is not carbonate. Similarly, when barium nitrate is added to sulfate solution, so it forms barium sulfate. Again, barium sulfate is solid and white in color. So B is also incorrect. In C, we have nitrate. So barium forms barium nitrate, which is soluble. So no visible change is seen, so therefore it could be nitrate. Similarly for D, it is barium chloride that is formed, which is also soluble. So no visible change is seen. As for D, both zinc and chloride are correct, so therefore answer is D. Question number 6. When aqueous sodium hydroxide is added to a solution, a white precipitate forms which dissolves when excess sodium hydroxide is added. Which ion could be present in the solution? A is aluminum ion. Now aluminum ion does form white precipitate and it is also soluble in excess sodium hydroxide. So A could be correct. B is calcium ion. It also forms white precipitate with sodium hydroxide, but it is insoluble in excess. So B is incorrect. C is copper plus 2. Copper plus 2 forms light blue precipitate, which is insoluble in excess. D is sodium ion. Sodium ion does not give any reaction with sodium hydroxide. The correct option is therefore A. Question number 7. Why does a balloon full of helium gas becomes smaller as the temperature changes from 30 degrees centigrade to 10 degrees centigrade? Now we know that when temperature is decreased, what happens that the kinetic energy of the molecule also decreases and so does the pressure. A. The gas condenses to a liquid and so takes up less space. Now helium does not condenses into liquid at 10 degrees centigrade, so therefore A is incorrect. B. The gas particles become smaller at lower temperature. Now this is also incorrect because there is no effect of temperature on size of the atoms. C. The gas particles diffuse through the balloon and escape. Now at lower temperature the diffusion rate will slow down. And diffusion only occurs when gas particles are smaller than the pores in the surface of balloon. At lower temperature, the rate of diffusion will be low, so C is also incorrect. D. The gas particles move more slowly, so reducing the pressure. As with low temperature, the kinetic energy becomes low and so does the pressure. When pressure is low, the size of balloon will become small. So D could be correct. The answer is therefore D. Question number 8. The diagram of an ion is shown. We can see the nucleus and first shell and the second shell and the charge is +1. What can be deduced about the number of protons in this ion? Now a positive charge means that this atom has lost 1 electron. Now we have 2 electrons in the first shell and 8 electrons in the second shell. So in total we have 10 electrons when charge is +1. So we can say that before making positive ion, this atom would have 11 electrons present. In neutral atom, the number of protons is always equal to the number of electrons. So if 11 electrons are present in neutral atom, so then 11 protons would be there. So in A it says 9 protons, which is wrong. In B 10 protons. In C it could be 11 protons. And D is also incorrect. So therefore answer is C. Question number 9. The circuit diagram shows an experiment using a rod of copper and a rod of graphite. This is the rod of copper and this is the rod of graphite. When the switch is closed, the bulb lights because an electric current flows through the copper and the graphite, which particles move through these two solids. As we know that copper is a metal, so what happens in metals is that the electric current is conducted by the presence of free electrons. Similarly, graphite is made up of carbon, and in graphite each carbon is making 3 bonds, so 1 electron is free for each carbon, so therefore conduction is on the basis of free electrons only. So in both, as only electrons move, so B, C and D could be correct. Now as copper ions and carbon ions does not conduct current, only the electrons do, so therefore it could be B or D for copper, and it could be B only for carbon. So in B, as all 3 options are correct, so therefore it is the answer. Question number 10. Which material has highest melting point? Melting point depends on the type of bonding for some compounds, while it also depends on the intermolecular forces of attraction between the molecules in other compounds. In ammonia, we have intermolecular forces of attraction between 2 ammonia molecules. As nitrogen is partial negative and hydrogen is partial positive, so the force of attraction is because the molecule is polar in nature. B is methane. The formula of methane is CH4. Now the force of attraction between 2 CH4 molecule, which is intermolecular force, is very weak. This is because methane is non-polar in nature. C is sodium chloride. In sodium chloride, each sodium ion is surrounded by 6 chloride ion, and in turn each chloride ion is surrounded by 6 sodium ions. So there is very strong electrostatic force of attraction present, which makes ionic bond. In water, we have hydrogen and oxygen present, and as oxygen is partial negative and hydrogen is partial positive, so it is also a polar compound. So some forces of attraction are present. So we can see that only in C strongest forces are present, so therefore the melting point and boiling point of C will be very high. Question 11. Which statement describes ionic bonds? A lattice of ions in a sea of electrons. This is the description of metallic bond, not ionic bond. So A is incorrect. B. Electrostatic attraction between oppositely charged ions. As in ionic bond, for example sodium chloride, oppositely charged ions are present and the strong electrostatic forces between them is called ionic bond. So B could be correct option. C. The sharing of electrons between atoms to gain a noble gas configuration. Now sharing of electron takes place in covalent bond. It does not take place in ionic bond. So C is incorrect. D. The transfer of electrons from atoms of a non-metal to the atoms of a metal. Now non-metal does not lose electrons, so therefore this statement is wrong. So D is also incorrect. The answer is therefore B. Question number 12. The diagram shows the covalent bonds in an organic compound. 2 carbons are present and 6 hydrogen atoms are present. The total number of electrons in one molecule of this compound is X. The total number of electrons in the bonds in one molecule of this compound is Y. Which numbers correctly complete gaps X and Y? We know that the atomic number of carbon is 6 from the periodic table and atomic number of hydrogen is 1. So in one atom of carbon 6 electrons are present. Similarly, in one atom of hydrogen 1 electron is present. As there are 2 carbon atoms in this compound, so there will be 2 into 6, 12 electrons. While there are 6 hydrogen atoms, so the number of electrons will be 1 into 6 equals 6. Now the total number of electrons will be 18 electrons. So it could be C or D. We can see that single covalent bonds are present. Now one single covalent bond comprises of 2 electrons. One is from one element and second is from second element. As we can see, there are 6 bonds between carbon and hydrogen and 1 bond between carbon and carbon. So in total we have 7 single covalent bonds. So the number of electrons in one covalent bond is 2. So 7 into 2 would be equal to 14 electrons in bonds. The answer is therefore D. Question number 13. Which contains the greatest mass of oxygen? A. We have 0.2 moles of aluminum nitrate. The formula is given. Let's find the molecular mass of aluminum nitrate. We have 1 aluminum atom, 3 nitrogen atoms, and 9 oxygen atoms. The atomic mass of aluminum is 27. For nitrogen it is 14. For 1 oxygen it is 16. So it comes equal to 213 grams per mole. If this molecular mass was taken in grams, so then it would be 213 grams for 1 mole of aluminum nitrate. As we have 0.2 moles, so let's find the mass of oxygen in 0.2 moles. As we have 1 mole of aluminum nitrate and the amount of oxygen present is 144 grams. So we can write 144 for oxygen. Similarly, for 0.2 moles given in the question, we would have X grams of oxygen. By cross multiplying, we can find the mass of oxygen. So in 0.2 moles of aluminum nitrate, the mass of oxygen is 28.8 grams. B. 0.3 moles of potassium sulfate. Now finding the mass of oxygen by same method, we have 2 potassium atoms, 1 sulfur, 4 oxygen in potassium sulfate. The atomic mass of potassium is 39, for sulfur it is 32, for oxygen it is 16. Molecular mass is equal to 174 grams per mole. Now we can see that the mass of oxygen present in 1 mole of potassium sulfate is 64. So we can write 1 mole of potassium sulfate has 64 grams of oxygen. Similarly, 0.3 moles are given in the question. So for 0.3 moles, we would have X grams of oxygen. By cross multiplying, we can find the value of X. The answer is equal to 19.2 grams of oxygen. So in B we have 19.2 grams. Similarly for C, we have sodium nitrate, which consists of 1 sodium atom, 1 nitrogen atom and 3 oxygen atoms. The atomic mass of sodium is 23, for nitrogen it is 14 and for 1 oxygen it is 16. The total molecular mass comes equal to 85 grams per mole. As in 1 mole we can see that 48 grams of oxygen are present. So we can find the mass of oxygen. For 1 mole we have 48 grams. For 0.4 moles given in the question we would have x grams of oxygen. Again cross multiplying. It comes equal to 19.2 grams of oxygen. So for C again we have 19.2 grams oxygen. Similarly for D we have magnesium carbonate. 1 magnesium atom, 1 carbon atom and 3 oxygen atoms are present. The atomic mass for magnesium is 24, for carbon it is 12 and for 1 oxygen it is 16. So in total we have 24 plus 12 plus 48 equals 84 grams per mole of magnesium carbonate. As in 1 mole we have 48 grams of oxygen. So we can find the mass of oxygen in 0.5 moles. By cross multiplying, the mass of oxygen will be it is equal to 24 grams. As we can see that the greatest mass of oxygen is still in A, so therefore answer is A. Question 14. Compound X has composition by mass of 63.6% nitrogen and 36.4% of oxygen. What is the empirical formula of X? For finding empirical formula, we can write the percentages as mass in grams. We have nitrogen and oxygen. The mass in grams will be 63.6 grams for nitrogen and 36.4 grams for oxygen. Now second step is to find the number of moles. Moles can be found by dividing mass divided by molecular mass or atomic mass in this case. So we can divide 63.6 with the atomic mass of nitrogen, which is 14, and 36.4 with the atomic mass of oxygen, which is 16. The number of moles are 4.54 for nitrogen and 2.275 for oxygen. Now we can simplify these number of moles by dividing with the smallest value. So we have 2.275, which is smaller one, so we can divide it on both sides. So the simple ratio comes equal to 2:1. So it means that in empirical formula of X, 2 moles of nitrogen are present and 1 mole of oxygen is present. So the empirical formula is N2O. The answer is therefore A. Question 15. The table gives the relative formula mass of 4 compounds and the mass of each compound present in 1 decimeter cube of solution. Which solution has the highest concentration in mole per decimeter cube? For concentration in mole per decimeter cube, the formula used is number of moles divided by volume in decimeter cube. As the volume of solution is given 1 decimeter cube, so therefore the number of moles will be equal to or would be the same as concentration in mole per decimeter cube. We can find the number of moles by dividing mass divided by formula mass. So for A, the mass is 3.65 and formula mass is 36.5, so we can divide to get moles. So it comes equal to 0.1 mole of HCl. Similarly, for second, we can divide 9.8 with 98. So the number of moles are again 0.1 moles. For third one, we have 2.8 divided by 56. The number of moles come equal to 0.05 moles. For last one, we have 6 divided by 40. Number of moles are 0.15 moles. As volume in decimeter cube is 1 for each of these 4, so therefore the concentration will be same as the number of moles. As we can see that the greatest number of moles are present in sodium hydroxide, so therefore the concentration would be 0.15 mole per decimeter cube, and it is highest among these 4. The answer is therefore D. Question 16. Which sample contains the most atoms? A, we have 0.5 moles of water. Now water is H2O and it is a molecule. B is 1 mole of carbon dioxide. Again, carbon dioxide is not an atom, it is a molecule. Similarly, methane is given, which is a molecule, and hydrogen chloride is also a molecule. Now for molecules, we know that 1 mole of any substance is always equal to 6 exponential 23 molecules. For molecules, we can use the formula number of molecules is equal to number of moles multiplied by Avogadro's constant. Let's find the molecules for each of A, B, C and D. For A, the number of molecules will be 0.5 into Avogadro's constant, which is equal to 3 exponential 23 molecules. For B, we have 1 mole of CO2, so the number of molecules will be 1 into 6 exponential 23, 6 exponential 23 molecules of carbon dioxide. Similarly, for methane, we have 1 mole, so the number of molecules will be 6 exponential 23 molecules. For D, we have 2 moles, so 2 into 6 exponential 23. Now we can find the number of atoms. As in one H2O, 2 hydrogen atoms are present and 1 oxygen atom are present. So in one molecule we have 3 atoms. Similarly, for carbon dioxide, we have 2 atoms of oxygen and 1 atom of carbon in 1 mole. So therefore there are 3 atoms in total. For methane, we have 4 atoms of hydrogen and 1 atom of carbon. So we have 5 atoms in 1 molecule of CH4. For HCl, we have 2 atoms in 1 molecule of HCl. Let's find the total number of atoms. For water, we have 3 exponential 23 molecules, so the number of atoms would be in H2O 3 into 3 exponential 23. It comes equal to 9 exponential 23 atoms in water. Same is for carbon dioxide, as we have 3 atoms, so 3 into 6 exponential 23 molecules of carbon dioxide, which are given. So it would be 18 exponential 23 atoms in CO2. For methane we have 5 atoms. So 5 into the number of molecules of methane, which is 6 exponential 23. So it comes equal to 30 exponential 23 atoms in CH4. For HCl we can multiply 2 with number of molecules of HCl, which is 12 exponential 23. So we have 24 exponential 23 atoms in HCl. Is the greatest number of atoms is 30 exponential 23 in CH4, so therefore answer is C. Question number 17. The diagram shows the structures of ethene and propene. This is ethene having 2 carbon atoms and this is propene having 3 carbon atoms and a double bond. Which statement about equal volumes of ethene gas and propene gas at room temperature pressure is correct? A. They contain equal number of atoms. Now for equal volumes of gases, we can say that equal volumes means equal number of moles. When number of moles are equal, then the number of molecules are also same. Now in ethene we can see that there are 2 carbon atoms and 4 hydrogen atoms, so in total there are 6 atoms in one molecule of ethene. While in propene there are 3 carbon atoms and 6 hydrogen atoms, so there are 9 atoms in total. If the number of molecules are equal, then the number of atoms are not equal because they have different number of atoms. So A is incorrect. B. They give equal volumes of carbon dioxide gas when burned completely in oxygen. Let's write a chemical equation. For ethene, the formula is C2H4. In the presence of oxygen, it forms CO2 and H2O. Similarly, for propene, the formula is C3H6. In the presence of oxygen, it forms carbon dioxide and water vapors. By balancing chemical equation, we can get 2 moles of carbon dioxide as there are 2 atoms of carbon on the reactant side. So we have balanced the number of carbon atoms. Similarly, there are 4 hydrogen atoms on the reactant side, so we can write 2 with H2O. Now we have 6 atoms of oxygen, so we can write 3 with oxygen to make it 6. Similarly, for propene, there are 3 carbon atoms on the reactant side, so we can write 3 with the product and 3 with hydrogen to make it 6. Similarly, now there are 6 and 3, 9 oxygen atoms on the product side, so we can write 9 by 2 with oxygen. So now 1 mole of ethene burns to produce 2 moles of carbon dioxide, while 1 mole of propene burns to produce 3 moles of carbon dioxide. So the volumes of carbon dioxide formed are not equal, so therefore B is incorrect. C. They give equal masses of ethane and propane when reacted with hydrogen. Now ethene will react with hydrogen to form ethane. The balanced equation will be like this: C2H4 plus hydrogen, it forms C2H6. Now double bond is converted into single bond and one hydrogen atom is attached to first carbon, while second hydrogen atom is attached with the second carbon. For propene, we can write C3H6 plus hydrogen. It will form C3H8. Now we have equal volumes of ethene and propene, so therefore number of moles are also equal. We can see that 1 mole of ethene forms 1 mole of ethane, while 1 mole of propene forms 1 mole of propane. Let's find the masses of ethane and propane. For ethane we can write C2H6, so there are 2 carbon atoms and 6 hydrogens. The molecular mass will be 2 into 12 for carbon and 1 into 6 for hydrogen. So in total the molecular mass is 30 for ethane. So mass in grams is equal to moles into molecular mass. Number of moles is 1. So 1 into 30 equals 30 grams. So ethane produced is 30 grams. Similarly, for propane there are 3 carbon atoms and 8 hydrogen atoms. So 3 into 12 for carbon, while 8 into 1 for hydrogen. Again, using formula, mass in grams is equal to moles into molecular mass. So 1 mole into molecular mass of C3H8, which is 44. So it produces 44 grams. So by hydrogenation of equal volumes, we get different masses of products. So therefore C is also incorrect. D, they react with equal masses of bromine. Now ethene will react with bromine in addition reaction and it will form C2H4Br2. Similarly, addition will occur in propene and bromine atom is attached with the double bonded carbon atoms and double bonded carbons turn to single bonds. Now we can see that 1 mole of ethene reacts with 1 mole of Br2. Similarly, 1 mole of propene also reacts with 1 mole of Br2. So when moles are same, so it means mass is also same for similar molecules. We can find the mass by using formula mass is equal to moles into MR. Moles is 1 and molecular mass of bromine Br2 is 160. So this mass is for both bromine molecules. The answer is therefore D. Question 18. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. The current is constant and the anode is weighed at regular time intervals. Which graph is obtained when the mass of the anode is plotted against time? When we have aqueous copper 2 sulfate solution, so the ions are copper plus 2, H plus, sulfate and OH negative. Both electrodes are of copper. We have to find the mass of anode that is being changed. As we know that if metal is present in its own ions, then what happens that the anode dissolves. Now we can say that copper anode will dissolve in copper sulfate solution. And copper will become copper plus 2 ions. Copper plus 2 ions move towards the cathode, they deposit in the form of copper solid. So the mass of anode decreases with time and mass of cathode increases with time. As the reaction takes time, so therefore A is incorrect because in A the graph is very steep and the mass of anode decreases abruptly, while in C the mass of anode decreases slowly, which is what happens in this reaction. In B and D the mass of anode increase, which is incorrect. This experiment is actually used for the purification of impure copper. So the answer is therefore C. Question number 19. Concentrated aqueous sodium chloride is electrolyzed using inert electrodes. Which row shows what happens in this electrolysis and why it happens? In concentrated aqueous sodium chloride, we have sodium plus ions, H plus ions, Cl negative ions and OH negative ions. As this is concentrated solution, so therefore the number of Cl negative ions will be larger as compared to OH negative ions. A. Oxygen is discharged at the anode. Now anions move towards anode, and among Cl negative and OH negative, what happens that Cl negative will convert into chlorine gas by losing electrons. This is because the concentration of Cl negative is greater than OH negative. So oxygen is not discharged, actually chlorine is formed. So A is incorrect. B. During electrolysis, the pH of the electrolyte increases. pH of the solution depends on the H plus ions and OH negative ions concentration. Now what happens that among sodium and hydrogen, H plus will convert into hydrogen gas by gaining electron. Cl negative forms chlorine instead of OH negative. So what happens that OH negative are still present in the solution. So the number of OH negative ions actually increase the pH of solution. So the statement is correct. Now let's move towards the explanation. The electrolysis in aqueous solution involves the discharge of H positive ions. As H positive ions are converting into hydrogen, and the balance between H positive and OH negative is disturbed. So therefore explanation is also correct. C. Solid sodium is discharged at the cathode. Now among the discharge of H positive and Na positive, what happens that the discharge of H positive is easy as compared to sodium positive. So therefore hydrogen is produced at the cathode rather than sodium. D. The products stay the same if the aqueous sodium chloride is replaced by molten sodium chloride. Now in molten sodium chloride, we just have sodium positive ions and Cl negative ions, and the product formed is sodium at cathode while chlorine gas is formed at anode. While in concentrated aqueous solution, hydrogen is formed at cathode and chlorine is formed at anode. So the products are different. D is incorrect. The answer is therefore B. Question number 20. The energy profile diagram for both the catalyzed and uncatalyzed reactions between nitrogen and hydrogen in the Haber's process is shown. What is the activation energy for the formation of ammonia in the presence of a catalyst? Activation energy is the energy that is required by the reactants to move towards the transition state. Now we have two transition states, one is this and one is at the top. Now what does catalyst do is it actually decreases the activation energy. So A is more than C, so therefore C is with catalyst while A is without catalyst. D is the activation energy for the reverse reaction in which ammonia is decomposed into nitrogen and hydrogen, while B is the enthalpy change between reactants and products. So C is the activation energy with catalyst, so therefore C is the answer. Question 21. Which statement describes the conversion of magnesium atoms to magnesium ions? We can write the equation. Magnesium atoms loses electron to form magnesium plus 2 ions. This is because magnesium is in second group of the periodic table and it loses 2 electrons to make positive ion. A. The change is reduction because there has been a gain of electrons. As magnesium is a metal and it loses electrons, therefore A is wrong. B. The change is oxidation because there has been loss of electrons. As we can see that magnesium has lost 2 electrons and it is a metal, so therefore B is correct. C. The change is reduction because there has been loss of electrons. Now loss of electron is not reduction, it is oxidation, so C is incorrect. In D, the change is oxidation because there has been a gain of electrons. As oxidation is the loss of electrons, so therefore D is also incorrect. The answer is therefore B. Question number 22. When water is liquid, it ionizes slightly and forms H positive and OH negative aqueous. The forward reaction is endothermic. When the temperature of water is increased, which changes take place? As this is an equilibrium reaction and the forward reaction is endothermic, so if we increase the temperature, what happens that water will move towards formation of ions and the reaction will move to the right side. Number 1, the water becomes acidic as by ionization of water molecules, equal number of molecules of H plus and OH negative are formed, so therefore the water does not become acidic, it is still neutral. 2, the water becomes alkaline, again the number of ions are same, so therefore the water is neutral, it is not alkaline. 3, more water molecules form ions as the reaction moves in the forward direction, so therefore more H2O molecules will convert into H positive and OH negative ions. So 3 is correct, as only option 3 is correct, so therefore answer is D. Question number 23. Which row correctly describes the solubilities of both ammonium sulfate and sodium carbonate in water? For the solubilities of salts, you should remember that all ammonium salts are always soluble. Similarly, you should also remember another statement that all sodium salts are soluble. So whether it is ammonium sulfate, ammonium nitrate or any other salt of ammonium, and sodium carbonate, sodium chloride, sodium sulfate or any other salt of sodium, they are always soluble in water. So ammonium sulfate is soluble, sodium carbonate is also soluble. The answer is therefore D. Question 24. Lead 2 chloride is an insoluble salt. Which two reagents are used to prepare a pure sample of lead 2 chloride? As lead 2 chloride is insoluble salt, so for the preparation of insoluble salt, precipitation method is used. What happens in precipitation is that two soluble salts are mixed together to make out a insoluble salt. A. Lead 2 carbonate and dilute hydrochloric acid. Now lead 2 carbonate is insoluble, so therefore we won't use lead 2 carbonate. In B, we have lead metal and dilute hydrochloric acid. Again, lead metal is insoluble metal, so therefore B is also incorrect. In C, we have aqueous lead 2 nitrate. As we know that all nitrates are soluble, so this is a soluble solution. Second is dilute hydrochloric acid, which is also soluble. So lead 2 nitrate will react with HCl in aqueous forms to form lead chloride salt, which is insoluble. along with HNO3 aqueous. Now, as these solutions are soluble and only this is insoluble, so this can be separated easily by filtration method. In D, we have lead-2 oxide and dilute hydrochloric acid. As lead-2 oxide is insoluble, so therefore it is not used. The correct answer is therefore C. Question number 25. The Haber's process is used to make ammonia. Which catalyst is used in the Haber's process? As we know that iron is used in Haber's process to make ammonia, so therefore answer is A. Question 26. Some compounds containing nitrogen are used as fertilizers. The table shows some nitrogen containing compounds, whether they are used as fertilizers or not, and a reason for this. Which row is correct? A. Aqueous ammonia. It is used as a fertilizer and it lowers the pH of the soil. As ammonia is basic in nature, so therefore it does not lower the pH, it increases the pH of soil. Because aqueous ammonia is actually ammonium hydroxide, which forms ammonium ions and hydroxide ion. So A is incorrect. B. Ammonium carbonate. It is not used as a fertilizer and the reason is that it is insoluble in water. As we know that all ammonium ions are soluble, so therefore B is also incorrect. C. Ammonium chloride. Ammonium chloride is used as a fertilizer and the reason is that it is made from the products of Haber's process, which is ammonia, and contact process, which is H2SO4. Now ammonia and H2SO4 can react together to form ammonium sulfate. As C is ammonium chloride rather than ammonium sulfate, so C is also incorrect. D is ammonium nitrate. It is used as a fertilizer because it is soluble in water. So ammonium nitrate is used as a fertilizer and it is also soluble in water, as we know that all ammonium ions are water soluble. So D is correct. The answer is therefore D. Question 27. An atom of which element has the same electronic configuration as an atom of an ion of strontium? Now we know that strontium is in second group of the periodic table, so it has 2 electrons in the outermost shell. In order to make ion, it will lose its outer 2 electrons and the inner shell is already complete. So we can write that strontium metal converts into strontium plus 2 and loses 2 electrons in the process. The atomic number of strontium is 38, so there are 38 electrons in neutral, while the atomic number is 38 but the charge is plus 2, so therefore there are 36 electrons in strontium plus 2. Now we know that 36 electrons are also present in an atom of krypton. So therefore the electronic configuration of krypton is similar to strontium plus 2. Also we know that metals lose electron to attain noble gas configuration. The answer is therefore B. Question 28. Metals are elements that have many similar properties because of their structure. Which statement about metals is correct? A. Metals are malleable. Malleable means that metals can be converted into sheets because of the layers of atom can slide over each other. This is a true statement. As an example, we have aluminum foils that are used in the form of thin sheets. B. Metals conduct electricity because their ions vibrate and pass on energy to each other. Now the conduction in metals is not due to the vibration of ions, it is actually due to the presence of free electrons. So B is incorrect. C. The melting point of metals depend on the strength of intermolecular forces in the lattice. Now what happens in metallic lattice is that positive ions are present surrounded by negative electrons. So the force of attraction between positive ions and negative electrons will result in the high melting point of metals. As only atoms are present, not the molecules, so therefore intermolecular forces are not present. C is incorrect. D. To form an alloy of two metals, the metals must have similar ionic radii. Now in the formation of alloys, metals are mixed together, and because of the different ionic radii, the sliding is difficult. So therefore alloys are harder than pure metals. So D is incorrect. The correct option is A. Question number 29. What happens when a strip of silver is immersed in an aqueous copper 2 sulfate? As we know that in reactivity series of metals, copper is above silver and silver is above gold. So the reactivity decreases. This means that silver is less reactive than copper. So therefore when silver is immersed in copper 2 sulfate, nothing will happen. So A is bubbles of gas, which is wrong. B is no reaction occurs, which is true, as the reactivity of silver is less. C is pink copper will be deposited on the silver strip. Incorrect. D is silver strip will start to dissolve. This is also wrong. Correct option is therefore B. Question number 30. 4 metals and hydrogen are arranged in order of decreasing reactivity. Which statement about these elements is correct? A. Aluminum is formed when aluminum oxide is heated with hydrogen. As we know that hydrogen is below aluminum, so therefore hydrogen cannot displace oxygen from aluminum. The reaction would not occur, so A is incorrect. B. Copper displaces zinc from aqueous zinc sulfate. Again we can see that copper is below in the reactivity series than zinc, so therefore copper is unable to displace zinc from zinc sulfate. The reaction will not occur. So B is also incorrect. C. Copper is formed when copper 2 oxide is heated with hydrogen. Now as hydrogen is more reactive than copper, so therefore when copper oxide is heated with hydrogen, it forms copper metal along with water. So C is correct. D. When added to water, aluminum forms positive ions more readily than potassium forms positive ions. As aluminum is less reactive than potassium, so therefore potassium ions will form more rapidly than aluminum ions. So D is incorrect. The correct option is therefore C. Question 31. Iron is extracted from hematite in blast furnace. Coke and limestone are added to the blast furnace. What is the function of the limestone? Hematite ore is made up of iron oxide. Coke is pure carbon. Limestone is calcium carbonate. Now when limestone is added to blast furnace, what happens that at a higher temperature calcium carbonate decomposes into calcium oxide and forms carbon dioxide gas. Now calcium oxide is basic in nature, it will react with acidic impurities such as silicon dioxide to form slag of calcium silicate, which is removed. A. It decomposes and neutralizes acidic impurities as it decomposes into calcium oxide and neutralizes silicon dioxide, so A is correct. B. It is a fuel which heats the furnace. Now calcium carbonate is not a fuel, so B is wrong. C. It oxidizes the iron in hematite. Now calcium carbonate does not react with iron, so C is also incorrect. D. It releases oxygen allowing the coke to burn. Now calcium carbonate produces carbon dioxide instead of oxygen, so D is also wrong. The correct option is therefore A. Question number 32. Carbon dioxide, methane, and oxygen are gases involved in the carbon cycle. Which of these gases may contribute to global warming? Now you should know that carbon dioxide is responsible for global warming as it traps heat. Similarly, CH4 is also responsible for global warming as it traps heat far more than carbon dioxide. So both these gases have major impact on global warming. So it is both carbon dioxide and methane, so therefore answer is B. Question number 33. Two statements about the water in lakes are given. Number 1. Fish are unable to live in some lakes because there is insufficient oxygen in the water. Statement 2. Fertilizers can be washed into lakes where they can cause eutrophication. Now eutrophication is the process in which we have oversupply of nutrients. Which will result in overgrowth of plants. And algae. Now algae blocks sunlight due to which photosynthesis stops, and what happens that dissolved oxygen becomes low. Now statement 1 is correct because fish cannot survive in insufficient oxygen. Statement 2 is also correct because fertilizers can cause eutrophication. A. Both statements are correct, and statement 2 explains statement 1 as insufficient oxygen is caused by eutrophication, so A is correct. B. Both statements are correct, but statement 2 does not explain statement 1. This is wrong. C. Statement 1 is correct, but statement 2 is incorrect. Statement 2 is also correct. In D, statement 2 is correct, but statement 1 is incorrect, so D is also incorrect. The answer is therefore A. Question number 34. Chlorine reacts with methane. Which row is correct? Now in CH4 we have 4 carbon-hydrogen bonds. And what happens is that chlorine first converts into free radicals and it replaces hydrogen atom one by one. So the product formed is CH3Cl, and this replaced hydrogen will react with another free radical of chlorine to form HCl. Now free radicals are formed when chlorine is exposed to UV light. In A, they have given the chemical reaction and hydrogen is produced, which is incorrect. In B, again the chemical reaction is given and hydrogen is formed, which is incorrect. In C, HCl is formed. In D, HCl is formed. And also we can see that CH3Cl is being produced. As this is CH3Cl, so C and D could be correct. Let's move towards the conditions. Methane and chlorine gases are mixed in the presence of UV light. This is correct. Methane is bubbled into concentrated aqueous chlorine. Now this condition is incorrect. The answer is therefore C. Question number 35. Which statements about alkenes are correct? Number 1. They have general formula of CnH2n. As for number of carbon atoms, the number of hydrogen atoms are double, so therefore 1 is correct. Number 2. They undergo addition reaction with steam. This is also correct. Because with steam what happens that hydrogen atom is attached to one carbon atom and OH is attached to second carbon and double bond is converted into single bond. So alcohol is formed. As no other products are formed, so therefore this is addition reaction. 3. They burn in air to form carbon dioxide and water. So C2H4 in the presence of oxygen, combustion takes place to form CO2 and H2O. So 3 is also correct. As all 3 options are correct, the answer is therefore D. Question 36. X is a branched hydrocarbon with the ratio of carbon atoms to hydrogen atoms being 1:2. X has a relative molecular mass of 56. What is the identity of X? Let's find the number of atoms of carbon and hydrogen. In A we have 4 carbon atoms, so we can write C4. And there are 6 hydrogen atoms, so H will be 6. Similarly in B we have 4 carbon atoms, so C4 and 8 hydrogen atoms. In C we have 4 carbon atoms and 10 hydrogen atoms. In D we have 5 carbon atoms and 10 hydrogen atoms. Let's find the simple ratio of carbon to hydrogen. So in A the simple ratio will be 2:3. In B the simple ratio is 1:2. In C the simple ratio is 2:5. In D the simple ratio is 1:2. So it could be B or D according to the ratio given. Now let's find the molecular masses. In B we have 4 carbon atoms, so 4 into the atomic mass of carbon, which becomes 48, and there are 8 hydrogen atoms, so the atomic mass of one hydrogen is 1, so therefore 1 into 8 will become 8 and it will be equal to 56. So the molecular mass of B is 56. In D we have 5 carbon atoms, so 5 into 12 for carbons, 60, and 10 hydrogen atoms. So for hydrogen it will become 10. So the MR is 70. The correct option is therefore B. Question 37. The reactions listed all involve ethanol. Which row correctly describes each reaction? In 1 we have 2 options, either combustion or oxidation. Let's look into the reaction. We have ethanol which reacts with oxygen to form ethanoic acid, and as number of oxygen atoms has increased from 1 to 2, so therefore reaction 1 is oxidation. So it could be C or D. In reaction 2 we have ethanol which reacts with ethanoic acid to form this compound. Now as COO is present in between carbon atoms, so this is ester and the name is ethyl ethanoate. So reaction 2 is esterification reaction. So in 2 we can write esterification. In third reaction we have glucose, which converts into ethanol along with the production of carbon dioxide. So this is a fermentation reaction. The answer is therefore D. Question 38. Ethanoic acid is reacted with propanol. What is the name and what is the structure of the ester produced? The reaction between ethanoic acid and propanol is esterification. We can write the reactants. One is ethanoic acid, which is CH3 C double bond O OH. Second is propanol. It consists of 3 carbon atoms and OH is also present. Now both these will react and water molecule is produced. And after removal of water, rest of the compounds attach to each other. So the product form will be CH3 C double bond O, and after this the carbon will make bond with this oxygen O. Then we have CH2, then CH2, and then CH3. We can also show all bonds of carbon atoms like this. We have 3 hydrogen atoms with first carbon, double bond oxygen with second, single bond oxygen, then carbon with 2 hydrogen atoms, then again carbon with 2 hydrogen atoms, and then carbon with 3 hydrogen atoms. Now naming this compound, we have 3 carbon alcohol, which is propanol. So the first name comes from alcohol, so it is propyl. The carboxylic acid was ethanoic acid. So second name comes from carboxylic acid, so it is propyl ethanoate. Let's look at the options. We have propyl ethanoate and the structure is similar to this one. So therefore answer is C. Question number 39. The diagram shows the partial structure of a polymer. Which type of polymer does it represent? Now in this polymer we can see that the linkage is of C double bond O NH, which is also known as amide linkage. So whenever amide linkage is present, the polymer is polyamide. So A is polyamide, which is correct. B is polyester. In polyester, the linkage will be like this. C is polyethene. In polyethene, the linkage is like this. In polysaccharide, the monosaccharides are linked by glycosidic bonds. The only correct option is therefore A. Question number 40. The diagram shows the repeat unit of a polymer. This is the repeat unit. Which row correctly identifies the monomer and type of polymerization involved in making this polymer? Now we can draw monomer from this repeat unit. The side bonds will be removed and double bond will become between these 2 carbon atoms. So it will be like this. As double bond is present in the monomer, so therefore the type of polymerization will be addition polymerization. We can also write these two in combined form. The monomer will be like this. There are 2 carbon atoms and 5 hydrogens, so we can write C2H5. Let's look at the options. In A we have addition, in C we have addition. In the monomer A, the double bond is present between these 2 carbon atoms, which is similar to this one. The correct option is therefore A. Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.